Hello, in this video I would like to solve a following problem. Identify parameters that determine whether the ball will roll or will slip down the inclined plane. Okay, so we have an angle of inclination theta and the moment of inertia calculated by the axis passing through the center of the ball is equal to 2/5 mr squared. Okay, so maybe let's start with pretty much solving the whole problem by writing the mathematical definition of rolling, which is that the velocity v is equal to angular velocity times r. And now let's take derivatives with respect to time on both sides. So here we get v prime, which is a, and here we get epsilon times r. And maybe now let's identify some forces that act on the ball. We have a force, a component of the weight that is pushing downwards. I will call it Fd. And we have a frictional force, a force of static friction that opposes the motion and that acts at the point of contact of the ball and the plane. And I will call it Fs. And we can write that Fd is equal to mg sine of theta, and Fs will be smaller or equal than mg mu cosine of theta. Fs is the force of static friction, and that's basically how the static friction works. We know only its possible maximal magnitude, but for most cases it will be smaller. Okay, and now maybe let's write what follows from Newton's laws. So we have that ma is equal to mg sine of theta minus fs, and we can write that I epsilon, it will be I calculated by the axis passing through the point of contact of the ball and the plane, but we will calculate that, so I will write maybe I1 is equal to epsilon. I1 times epsilon is equal to the force pushing downwards, so again mg sine of theta times r. And now I think it's pretty much it. We just need to solve. Maybe let's just calculate the I1. I1 in this case will be equal to mr squared plus 2/5 mr squared. Okay, and now we need to solve this equation. So from this equation follows that epsilon is equal to mg sine theta times r. Like a weird notation, but who cares? Divided by I1. The masses will cancel, but not now, maybe. Okay, and from this equation we have that Fs is equal to m times g sine theta minus a. And now pretty much we can substitute the epsilon here and a here. So I will write that Fs is equal to m g sine theta minus, here I will substitute this expression for epsilon to the expression for a, and I will get mg sine theta times r squared divided by 7/5 mr squared. R squares will cancel and masses will cancel. And what we are left with is that Fs is equal to, here the 7/5 will go up, so I think we will be left that Fs is equal to 2/7 mg sine theta. Okay, yeah, definitely, 7th mg sine theta. And now we can substitute to this inequality. So we get that 2 7th mg sine theta is smaller or equal to mg mu cosine theta. Mg will cancel, and I will divide by the cosine of theta and multiply by 7/2, and I will get that tangent theta is smaller or equal to 2/7 mu. Sorry, of course not, 7/2 mu. And what follows from it is that theta is smaller or equal to arc tangent of 7/2 mu. And if that condition is met, we have rolling, and if it is not met, we have slipping.